So Spark is quite new, and Spark, Storm, and all of that is actually working out fast. And let's see how it goes. Okay. So again, let me just move to the next problem. So how many of you give it a try? So the second problem which we had was this, right? So you are given a content from a very large text archive. Formulate the next words for recommendation based on the current word. So, so did anybody give it a try? Other than I just got Anto's answers, those were quite close, and 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 some more people also wrote. Okay, 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 okay. I mean, it's pretty good, fair if you write it in Google Doc because it becomes very, very easy to review. If you respond with the Google Doc rather than an email, it becomes very easy for me to review. I can pinpoint each and every thing and say, why is this so? Why not this? So, yeah. So Google Doc is good, is better than other forms of, way of reviewing. Also, you can come online at the same time and then we can have a chat quickly if you have written your answers. Okay. So for others also, if you're solving your problem and it is of decent size, then prefer a Google Doc. It makes it very, very easy to review. I haven't found any comparable tool in the enterprise world which we can buy. So now let's talk about this. So I gave it a basic try. Okay, here is my solution. So what all I did was my mapper converted each line from uh, convert from the pairs of the world. How are you? Okay, and then my reducer is going to group them together. Okay, now the problem is, do you see any problems with this solution? Anybody? Okay, okay, yes, Bhagavat. Too many, okay. Two times the number of words approximately, yes, that is okay. How is that? A lot of data comparison, okay. If you eliminate some words, right, right. But how can you eliminate some words? On what basis will you eliminate? So basically, this is true that this will approximately create twice the total amount of data. Okay. Suksavat is saying that he has downloaded the content. Great. and has no idea how for separating by each word. Yeah. So basically, if you are using any of the streaming jobs, right? So they will give you line by line content. Okay. And you can split each line in your the way we have done earlier. You can split each line by words and then form this kind of using your programming language. Okay. Any code you are planning to write that way. Okay, let me go through lot of comments are coming. Bhagwat is saying I would create a word and its previous word as the value. Create a word and its previous word as the value. Why will you say so? Because we are not looking giving what at the end of it, what are we doing actually? Given a word, we should be able to get five recommendations. Okay, so the word has to be the key wherever we keep it, in memory or anywhere we keep it, it should be available. So the general strategy to solve such problems is on the architecture level is have a in-memory database such as Redis or anything else, and let that in-memory database load all your results. Once you have prepared your frequency table, once you have prepared the outcome word versus the five top recommendation, you load it in Redis. So the Redis will be keeping the key as your first word and values as the top five candidate for the second word suggestion. Redis is a big in-memory database. Okay, so if you can afford a database of say 90 GB, or so, it will load everything into the memory, and it will be extremely fast for key value lookups. It will be extremely fast for key value lookups. Okay, or maybe MongoDB. MongoDB also extremely fast for this kind of job. So once you have generated all of your output, you give it to something like Redis or Memcache or something which can give you key value pair kind of extremely fast speed. Okay. Now, just give me a second. I need to go through everyone's comments. If you eliminate some words, I would create word and previous word. No, I am done. Okay. As Hadoop uses HDFS, um, right. So Hari has got the right problem. Hari is saying that file chunking will eliminate some pair. Very true. Very true. Yeah. Okay. So Chintamani, nothing to worry. We were just having discussions right now. Okay. So great. So basically, there are multiple problems with this approach. Okay, let's have a look at few of the problems. First, since in the general MapReduce way, our input is broken by line. So our mapper, the instance of each map function is being called on each line. On line by line, it's being called. Now, since so the last word of the line should pair with the first word of the next line. How will we make that happen? Okay. And also mapper knows about the line number in general. Okay. So you can use that kind of information to solve it. And second is the last word of a sentence should not be paired with anybody. Okay. Third is when computation of frequency or top n candidates for a word becomes too big, then we can further do our map reduce there. Right. We would not do that. We would not pair beyond a period. That's what Bhagavad is saying. Okay, good. So first problem we have understood. Since MapReduce is giving you the input in line by line format, it is extremely difficult to pair the last word with the first word in the next line. So you should be paired with Ram, okay, which is not being paired. How are you Ram? You and Ram should be paired. Similarly, birthday 2 should be paired. Okay, that's what we have missed it out here, right? Although if you have very large text, these problems could be eliminated. Okay, because if you have large enough text, so by way of statistics, the last word, these problem could be overlooked. Okay. Now Bhagwat is suggesting that remove new line, right? Now the third problem which Hari is saying, that what about chunk size, right? So when it is dividing by byte count, how is it going to happen? Okay. So these kind of things and also note that mapper, your map function is availed the location of the byte count. Okay. So okay, I'll come back to these details again. Let me, uh, so these are the few things you need to know. So these are the kind of problems we will face while creating mapper and reducer. And can we solve those? Yes. But how? That is the mechanism. How are we going to solve those problems is what we are going to discuss today. Okay. Now, now let's move on. So we'll get into really detailed analysis of things today. If we split files into chunks and assign each split to a mapper to the process, it split file chunk and assign each split to a mapper to process. Okay. Yes. That's what we are going to discuss today. Okay. Okay. Again, little bit of recap. Let's see how many of you have understood things. So quickly, this is an exercise which tells me that you are with me. The data generated by mapper is given to reducer. Then it is sorted or shuffled. Yes or no? Great. Anybody thinks it's correct? Great. Right. So the output of the mapper is first shuffled, sorted, and then reducers are called upon it. Great. Perfect. Now the mapper, next one, first one seems everybody correct. First one, second one. The mapper can only generate a single key value pair for an input value. Is that true or false? Mapper is giving us a line or something. So can it generate multiple key value pairs for an input value? It can generate, right? That means the answer to this question is no, because it says the mapper can only generate. Only is the keyword. Okay, so yeah, right. So probably you all mean to say that mapper can generate a single value pair for an input value, right? So the answer to this question is no, because the keyword here is only. Okay. So the mapper can only generate a single key value pair for an input value. No, it can generate multiple values. It can generate multiple values for, you remember we were given a line and we were splitting the words and we were generating multiple key value in the mapper. Line 1, word 1, word 2, word 3, and on so on, right? It can generate. Perfect. Now let's move on. So, okay. So by default, there is only one reducer in case of streaming job. Yes. Okay. Okay. By default, there is only one reducer in case of streaming job. Right, right. So in case of a streaming job, you remember in case of a streaming job, all it does is sort the data and give the whole output after sorting. It doesn't group it and gives to the streaming job. So it's a single value, although you can configure a streaming job by mentioning an argument saying I want these many reducers. But by default there is only one reducer. Okay. What is the role of job tracker? Executing map reduce logic, or delegate the map reduce logic to task tracker? Excellent, excellent. Great. So everybody understood that it is B. Now the map logic is executed preferably on the nodes that have required data. Yes or no? Okay, great, great. But remember that in case of emergency, when all the nodes which contain the data are heavily loaded, if they're heavily loaded, then a map logic or reduce logic, sorry, a map logic can go to the nodes which don't have the data. Okay. The whole of the chunk available on a node is fed to the mapper. Just a second. So Bhagwat's question is, how will that work? If we are sending mapper to a node which does not have the file chunk, how will that work? That is the question posed by Bhagwat. Yeah, that's an interesting question. So in that case, that particular node will ask HDFS to give the data. Basically, it's asking the other node to give it a data. Okay. So first data transfer will happen, then the mapper will execute. Okay. So it's too much of data transfer. Okay. And the way map logic works is that, say you are trying to execute a logic which is little intensive. We have a record because Hadoop also keeps counters, a record of the how much time did this particular process take. And all the task nodes are busy. They are busy in doing things. Okay. The all the task trackers or the individual node are very busy, and hence what Hadoop will do, or your job tracker will do, is find out where are the replica of that chunk is existing. Now all the replica as well as that particular node is busy. Okay. So, or say we want to execute a map logic on a particular data. Now this data has got three replication. All three replications are extremely busy. Okay. Now Hadoop will find out the nearest node to the node which contain the data. Okay. Using a network topology. I'll come into those details today. And then it will execute on the nearest node. Okay. If the same node is existing on the nearby machine which is connected to the same router, it's extremely fast as compared to the geographically separated machines. Okay. And that is how it works. I'll go into details today. Now this question, who can answer this? The whole chunk available on a node is fed to the mapper. Okay, okay. Arun, can you explain your answer? So only Arun is saying no. Okay. Okay. So Sasank is saying it locates task tracker node with available slot at near the data. Okay, that was your answer to the previous one. Good. This one, Hari, you yourself raised this question, right? The whole of the chunk available on a node is fed to the mapper, yes or no? You remember the input we have given to our MapReduce logic is in terms of lines, right? And the way HDFS divides the chunk is in terms of bytes. It has nothing to do with lines or words or anything. It just divides it in the bytes. So what happens in the case is when half of a line exists in one chunk and rest of the line is available in another chunk, or half of the word is in one chunk and another half is in another chunk. What happens in those cases? So in case the whole chunk is being fed to the mapper, our frequency count, which we had been talking earlier, will give the wrong results, right? We are counting the word's frequency, and if it is sliced up into two, and that happens everywhere, then it becomes a problem. So Bhagwat is saying that it runs at both the location. If it runs in both location, then also the frequency will become double for that word. Oh, okay. Okay. No worry, Chintamani. Try to solve the network connection problem. And yeah. Okay. Let me again rephrase my question. So Arun, do you want me to rephrase the question? But Hari is saying, but chunk available on the node. Here the keyword is whole of the chunk. Whole of the chunk available on a node should be given to mapper or not. Okay. Let me again ask this question. So question is, remember we talked about SDFS, and as for SDFS, it divides your file into 64 MB chunks. So that is called each chunk. Okay. Now each chunk is divided in terms of, it is divided like irrespective of whether you are slicing a word or slicing a sentence, irrespective of everything. Okay. I- So half of the word might exist in one chunk, while half of the word might exist in another chunk, right? So if the question is the whole of the chunk available on a node is fed to the mapper, is it correct? The answer is no, right? I'll come into more details today. Okay. Till then, let's, yeah, great, great, great. So let me just take a step back here. The idea of asking this question is to get your facts right and convince you that what I'm going to talk is important. Okay, so let's now go back. Now input is split using input splits, and part of which is transferred to other mappers. This is, if you don't understand this sentence, don't worry. Okay. So Bhagwat, I forgot to look at your answer. And the partial unit of data may be sent to the, yes, yes, sort of, yes, sort of, the partial data is sent to the other. So here, let me again repeat, no, the whole chunk is not fed to the node or fed to the mapper. The input is split using a class called input splits, part of which is transferred to other mappers. Okay. So input splits is quite a flexible thing, and I'll talk about it more. Where does Hadoop store the results of reducer? In HDFS or in local file system? Anybody? Okay. No, actually. No, actually. Okay. So basically, oh, sorry. Okay. I'm sorry. I read it like, where does Hadoop store the results of a mapper? It is HDFS. You are all right. Right. You're all correct. Yes. Okay. 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 Great. So great. Yes, it is stored in HDFS. Now the question is, where does Hadoop store the intermediate data such as output of map task? So mapper generates key value pairs on each node. So does that data go to HDFS, or is it stored locally? Quick. Where does Hadoop store the intermediate data such as output of map tasks? Excellent. Yeah, this one is the one, it is local. So on the local file system, Shashank, it stores the intermediate data. Okay, so uh, say basically we are running a job, running 100 mappers on 100 task trackers. Okay, now each mapper is going to generate its output, and it is going to save that output locally. Not really. Chintamani, the thing is that Hadoop stores the final and initial reads from HDFS and writes directly to the reducers. The output of reducers is stored in HDFS, right? Here, it's a intermediate data. It is on the local machine. Okay, okay, not clear. Why this distinction not clear? Good. Okay, let me again rephrase it. So when Hadoop, yes, yes. So data nodes performance is based on that local configuration. Chintamani's question: what does it store? Part here and part there. Let me. Yeah. So your mapper ran. All your mappers have run. Now the output they generated, the key value pairs they generated, each of those will be keeping on their local machines instead of keeping in the HDFS. Okay. Now part here and part there. Yes. Let me explain that. Now this is a temporary data, because this is going to go ready to reducer, and then it is going to go to the the HDFS. The output of reducer in the previous question is saved into HDFS. Now uh, before moving the data from each node to the reducer, couple of things happen, such as sorting of the data, right? Now, before sorting the data, if we start keeping the unsorted data into HDFS, it will be too much of unnecessary things, because this is a temporary data. It is going to get sorted and then deleted. Okay, there is no point in having replication and all that magic in place, right? So this is a sort of temporary data. So you are getting my point? So that is the reason why it keeps it part here, part there. It says all the mappers keep their data to themselves. We will, while sorting, we'll have our output. You can delete your data. It is that way. Okay. So that is the reason why it keeps the data output of the mapper, not reducer, mapper, into a temporary file locally. Once the data is sorted and merged and is being fed to various kinds of reducers, then we can ignore it. Yeah, you can think of it like a RAM, or you can think of it like a temporary files. Okay. Okay. So that is the way it is. Now, why today we are going to talk about map reducers in Java. So, how many of us are okay with Java? Who can once look at the code, they can vaguely identify that hey, this code is doing that. How many of you? Okay, Bhagwat is okay. Gaurav is okay. Hari is okay. Okay, Arun is not. Suksavat is okay with Java. Shashank is not. Okay. Chintamani, are you there? Okay. So basically, Anto is okay, but not practical experience. No, do not worry. If you have just read the theory, that is good enough for us. Okay. Chintamani has gone offline. Okay, great. So this class we are going to talk a bit about uh, MapReduce in Java. I will try my best to keep it very simple. So do not worry in case you don't get it in the first time. Okay. And you can drop me a message personally also in case the whole map reduce is not clear to you. Okay. In Java. So do not worry about, I mean, it won't be that difficult. Okay. Let me try today. So why are we going to talk about Java? So we talked about Hadoop. We talked about that the Hadoop was written in Java. Okay. Okay. Hadoop was written in Java, and the basic objective of writing it in Java was that Java is the most compatible language and most popular language out of all the other available. Okay, right. It's a platform independent language, right? Okay. So, Chintamani, are you okay with Java? That was our question. How comfortable are you with Java? Okay. Oh, never mind. I think his connection is very flaky today. Let me check if my screen recording is going on. Yeah. And why are we talking about Java so much? Because it's primarily supported in Hadoop, because it is written in Java. Second, a behavior of Hadoop can be to a very large extent, customized if we know Java. Okay. So, so most of the job of MapReduce can be done in almost any programming language using the streaming. Okay. So because using Hadoop streaming, we can actually do lots of data churning and lot of customizations also. But to alter the behavior of MapReduce itself, or a lot of things could be done if you know Java. But the important part is most of those kind of things people have ported in other languages. So you can customize in other language like Ruby, C++ also. C++ also you can write very, very robust map reduces. Okay. Okay. Okay, great. And also Python also. Now, these are the first steps to for writing in writing a MapReduce. First, you install Eclipse, create a Java project, and add these libraries. So I mean I have shared a zip file online in this sessions uh, page. There is a zip file under which there are two folders. One is project, other is your all the jars required. And I mean the most stable version of Hadoop is 2.4 probably, is the one which we are using right now. And so that is why please change your JDK from 7 to 6, and then Java compiler settings to 1.6. So these are the basic setup. Okay, so I'll just show you quickly how we are going to do that. Okay, so let me just open my Eclipse. I have got Eclipse installed. You can install Eclipse, download a zip, and that's it. So basically, in Java, you can do a lot of magic in uh, while customizing the MapReduce. Okay. So here is my. So should I create a fresh one for you? Let me just close this project. Okay. Now let's say I create a new project, new Java project, and I say it training 3. Okay. And here I can select JRE 1.6, and that's it. Okay. Now this is my blank project. Now I can create a simple, I will come back to that very quickly. And other than that, you can just check your Java build path and all here and add your external jars. Those all jars are available in a lib folder. After you download the whole project, you will find these two libs. Also, you can, whatever project I have uploaded, you can import that project like this from the existing into the existing workspace. You select that project and that's it. Okay. Okay. So I haven't planned for minimal Java Premier, but okay. Let me think of a way. So basically, this is your Java Eclipse ID. Once you little bit roam around here, you say, okay. So this is my Eclipse environment. I created a new project called training, and there I can quickly say new class, and then say something like hello world. Okay, hello world. Okay, and then I can also say great. Now it has automatically created me a class. This is where I will write my code. Okay, this is my automatic. So this is my empty class. If I run it, you see this button here. You can click on this and you can run this, and it will do nothing right now. But if you write here a syntax like sysout system.print line and say hello world, okay, this will print it. So hello world is the basically everything, every file is a simple class. Okay, whatever file name you keep, you also give the same name here. Like hello world.java is the file name and hello world is my class. Under that we have a function. We have a function. If you name it public static void main, it will be run by default. Exactly. So it is just like println in Pascal and printf. Yes, perfect, perfect. And then you run it. It says hello world. You see the output here? It says hello world. Okay. This is how it is going to look like to you, right? And if you have to extend another class, say you want to change the behavior of some other way, you write here hello world class extend something. Okay. And if you want to implement an interface, I mean, you just remember that extending another class is possible. That will be good enough for now. Okay. If you want to extend some other code's behavior, all you can do is extend this. So right now, this will be sufficient for you. Okay. So this is the hello world in Java. Okay. This is the way we declare a function. Public, static, void main. These are various modifier to the functions. And then you have a function which accepts some arguments. These are the arguments which will be passed to the command line. When you execute hello world from command line, then these are the arguments you will be passing. And here we go. Okay. So this is as simple as program as could be. Now let me just move ahead a bit so that now let me just open up my actual project. This is my actual project. So it has got, this is, if you see this top node is the project node. It has got a folder called src. Under that src, these are my files. Okay. So I have created 4 files. Out of this, 3 are important. Okay. Let me just open the first one. I'm closing my hello world and then opening my mapper. This is the logic of the mapper. Okay. You remember the way we wrote mapper earlier. So when we are coding in Java, so we say my class name is some mapper. This is up to you how you want to name it. Okay. This is how you want. Yes, yes, yes. You are right, Chintamani. You are right. You are you're right. So this is exactly the way you have understood it. So public class, and then you have a class name, stub mapper. This is up to you, whatever you want to name. And then you say extends. So any mapper you are trying to create, the logic for mapper you are writing, it has to extend a mapper. Okay. And while extending a mapper, it defines 4 types. Mapper is another class. Okay. Yes. Mapper is another class which does not, which is probably abstract. Okay. Which is abstract class. If you click on the, if you click control click, then you will get to this screen. It will show you the definition also. Okay. And also if you keep cursor over that, it will give you a lot of details. Okay. Now stub mapper extends a mapper. Okay. Let's just ignore the angle brackets for now. And then when you are extending mapper, you have to implement a function called map. This function. Okay. You have to extend a function called map. And in this you write your actual logic. This is where you write your actual logic. Okay. This is where okay. So each mapper is given a key, a value, and a context. This is the input to the mapper. Yes, yes. So if you just delete this function for time being, so now it will say okay, it did not. Okay, just a second. I think it will. Oh, okay. Actually, since it's a abstract class, it's not adding. But you can add it by yourself. So the thing is that Mapper will be, you'll have give you these two values, okay, which is key and value. Every mapper code will be given a key and value. Unlike streaming jobs, in case of streaming jobs, you were given line by line content. Here, the value will be line and the key will be the bytes, number of bytes, which you will be given. Okay. At what byte your line is starting. Okay. And then this is where you write your output. So what I'm doing, I here I took the value which is the line, I converted into string and then said split. Split by space or tabs. Right. Now, yeah, override is an annotation which says that whatever behavior of map was there in the parent class, which is mapper, override it by with this function. I am overriding the behavior of map. Okay. This is how it works. Now, once you have splitted this line by space and tabs, you get an array of words. This is an array of words. Okay. This is a string. This is representing that it's an array of strings. And now I iterate over word by word on this array of words and print this. Where am I writing it? I'm writing into context. Context dot write new word, new text and word. So I'm creating an object here called text and giving it a word, and then I'm saying one. So instead of ideally the better code would have been like this. I say write and one. Okay. This could have been better. But since uh, I mean everything it tries to create object, it's a separate kind of object. That is why they have come up with, instead of a standard string, they have come up with something called text, and they come up with something called long. Okay. And that is why instead of straight away writing that I am giving a string in Hadoop world is equivalent to text. This is a Java string, word is a Java string, and text is the string by. Okay, okay, thank you, Arun. To yeah, let me see if I can. Oh, I can. Can I increase the font by any chance? Window run window, bring all to the front, zoom. Can you zoom? Window, zoom, zoom. No, I don't think. I'm actually trying to look at how do you change the font. I never needed to change a font. Maybe it's in the okay file. Let me just go into the project settings, and then I have Java, then I have editor, then folding, hover, syntax, save actions, template typing, content assist, folding, hover. Okay, editor. There, color and fonts. Okay, let me just increase this to say 24. How will it look? I hope it doesn't look really, really horrible. Oh, now it looks neatly horrible. Let me have a look at it. Yes. Can you see now? Okay, great, great. Now, basically, instead of writing just simply words as a string, I mean, Hadoop has come up with a class called text and long writable. Okay, so this is how we write. Great, great. This is how we write a stub mapper. Basically, we are trying to write, our objective from a mapper was that give us some key value input data and we will generate key and value. This is what was the objective of writing this much of code. Okay, so we are given input line in value and key in the key is the byte, nth byte, the byte count of the key is not used right now because we don't have anything to do with the byte. Okay, you can think of key as line number, but it is not really line number, it's a byte from which your data is starting, because Hadoop doesn't really know the byte line numbers. HDFS doesn't really know the byte line numbers because it's a property of the it's a property of somebody else. HDFS basically knows only bytes. So here this is bytes, this is input line, and this is where you write your output. So we said context dot write, this is my key and this is my value. Okay. So this is what our vaguely our mapper looks like. Okay. Now let's have a look at our reducer. There is another class called reducer. So we wrote our mapper job. We are still talking about the same problem of frequency here. Okay, so all we have done is took a line, or let me just call it a line. Okay, so we took a line and we took a line and then we have split it by space and tabs, and then we wrote the output as word comma 1. 1 is that number value. Don't get intimidated by new long writable. I'll come back to that. And now let's have a look at our reducer. Now you can imagine how will your reducer look like actually. This is how your reducer will look like. Whatever output your mapper gave in terms of key and value will be given to reducer after sorting and merging together. So what does reducer get? A key, an array of values. Okay, this is iterable values. Okay, so you can iterate over values, and again reduce also given an object called context, that's where it will be writing its output to. Okay, now we have initialized a variable called sum. Don't go by throw exception and all, we'll talk about later these part. So this is my class name stub reducer, which is what is the same file name also, and extends reducer with these kind of data types. We'll talk about these data types again. So we are extending a class called reducer, which has got almost all the behavior, and we are overriding a function called reduce. So whatever reducer has the whatever properties reducer has, they will remain as is. Only we are overriding the reduce function because we want reduce to be ours. Okay, and what do we want to do in the reduce? We want to sum all the values for the key. So we have defined a sum as long, and don't, I mean, if you are dealing with big data and big numbers, try to keep it long rather than keep it integer. And then we are iterating over values. We are saying get me one, all the iterate over these values. Okay, it's like it's a for loop which iterate over the list of values, and then it is summing up all the values into sum, and then at the end of the process it is writing it to the context. The sum and the key are being written to the context. Okay. So in this reduce function, what we are trying to do is basically we are iterating over the values and then summing it up and then writing it to the context. Okay. So this context.write does the output while your input values are available as the function argument. Okay. Okay. In the for loop, what we are doing is well iterate over each value of values, and in the values what we are doing is here this declaration means my IW is a variable. IW is a variable for into which it's this is equivalent to saying this. Okay, I'll just say, let me just try to write this. If I do this int I equals 0, I less than values dot, okay, or you can think of it as while values dot has next. Okay, just think of it in these terms. Okay, so basically we say you can think of this whole loop as while values has next, then we say long writable. Long writable is equivalent to long value, and we say values dot next. This is what this code looks like. Okay, we are basically iterating over the values. All right. So this is what it is. Now for those people who are from, yeah. So now you can have a look at the map. Yeah, this is like your word colon verbs, right? So it's the same for loop. Okay. Now for those people who are interested in knowing what is this, unlike our streaming job where everything was plain text, in case of Java, we can define the data type of our inputs and outputs. Okay, so while you are extending mapper, you can say that the key which I am expecting in the form of object is in the form of object, while the value is also in the form of text, and the stuff which I am going to give out to you will be the key will be text and value will be a long. Okay, so while I'm extending mapper behavior, I am saying that hey, I want to change mapper's behavior such that the key which I'm going to expect is object, value which I'm going to expect is text, and the key I'm going to give out is text and long writable. And you can write anything here. Remember, whatever you write here, okay, whatever you write here is going to go to reducer, right? So when you are defining here, these two values will be same as these two values, okay? Because anything comes out from the reducer, these two data types of output of the mapper is going to be same as input to the reducer, okay? So why similarly when I'm defining reducer, I'm also saying, hey, my data type is different from the standard. My data type is I'm expecting an input key in the form of an object called text, okay, and my input the input value which is going to be long writable means long value, a long number, and I'm going to give out text and a number. Okay, so this is how we generally stitch a reducer. So we defined when we say how did we create a mapper, we extended a mapper object, also told that these are the various data types which we are expecting, and remember whatever data type you give here will also appear here. Okay, whatever key values are there. And similarly in the context when you are writing, you have to ensure that you are writing whatever you have promised above. So these are the template things in which you say that this list or this data is going to be only integer or only this and that. Okay, So just to ensure the type safety, just to ensure the type safety. Yes. Could we send the object as a value? Yes, yes. Anything you want to do, you want to extend anything, you can extend by yourself also by extending a class called writable. You want your own kind of data type, which you have you have fancied that, hey, I want to use this kind of value as a transfer mode between the reducer and mapper. You can define that one. Just that you'll have to define the keys and values properly. Right, right. So data type, whatever, this is to ensure that you have a data type safety. Okay. Say for example, in case of a streaming job, the separator between key and value is a tab, right? What if your key contains a tab? So those kind of problems arise if you don't have a type safety in place. So these kind of languages which are giving ensuring you the data type safety. Okay. Now let's have a look at. So these are two things. This is my mapper. This is my reducer. Now we have to stitch them together to generate do some meaningful job, and that is what our step driver does. Step driver is just another class. It does not extend anything. All it does is it creates a job. Okay, it gives it a name called a word count, which is will be visible on the portal. So we created job equals new job, meaning I'm creating an object. You see a strikeout, don't pay heed to it. It is just saying that this class has been deprecated. Okay. Now, right now, what you do is you say some name to here, and here the most important part to remember are these two. Okay, where I say job.setMapper class, job.setReducer class. These are the class names which you have just created. Step mapper. Just sorry, some people are trying to dismiss. Okay, so I'm setting a mapper, whatever just created, and a reducer, and then I'm also defining what kind of value I'm expecting as output. You remember the output of a reducer is a text, and output value is a long writable. Similarly, these things I'm again defining. Now this is important. Here I'm adding input paths. All right, this one, right? Yeah, I deleted. Actually, that is not required. Okay, that's not much required. We can just say this way also. Okay. Now we add input file like this. Okay, file input path, and then this arg0 here. Arg0 is argument passed as a command line to this file, and arg1 is command argument passed in the command line. So first argument, second argument. And in case first argument or second argument is missing, we display an error like the syntax is this. We'll show this error whenever argument length. These are the argument which, so this is our entry point. Step driver is our entry point, and whatever arguments you are passing in the command line are availed here. And the first argument arg0 is the first argument, and arg1 is the second argument, and then we wait for job to complete. Okay, and then exit. Here is something which is awkward, which is system.exit. Basically we are stopping the JVM. Okay, now this is what it is. Once you have written all of this, Once you have written all of this, what you do is, so you have written three classes. One is mapper, okay, which extends a mapper class, and then another is reducer, which extends reducer class and adds a function called overrides a function called reduce. And then we wrote a step driver. Driver is the one which stitched together mapper and reducer and our input file and output file. Okay. Now what do we do next? So once you have created these objects, what do you do next? We have created a driver. Now you export the jar. How do you export a jar? Say this is the one which you are writing right now, and then you say export and select jar from the top and next, and then create the jar file. I'm creating here in my home folder called training2.jar, and that's where I'm going to create. It exists. I'm overriding it. Okay. So So what does it mean? Gaurav is asking what does this statement means. So when we are calling system.exit, we also pass in a exit value. The way it happens in case of a C, we say exit and then we say 1 or 2, right? Here, here if result is true, okay, we pass 0. If result is false, we pass 1. As part of Unix standard, we pass 0 in case the process successfully completed, and we pass non-zero if there was an error. Okay, so result, if it is false, then 1 is given to exit, and if result is true, then 0 is given to the exit. Okay, here. So as part of Unix standard, in case there is a code, your program is giving error, you give an error number. If it is successful runs, then you give a 0. In that case, right, right. This is like if and then, exactly. So it means if result equals true, then 0, and then, yeah, right, right. So if you have worked on any programming language, you should be able to get it, except for templates and extension. Rest of the things are straightforward. These things which these parts where we define the data types. Okay, so that's it. So we have stitched it together. The we have exported the file to the command line. Now what we will do is we'll copy it. We'll copy it to the Hadoop server. Okay. Now let's just take it to the Hadoop server. Okay, okay. Can you see the font now? So uh, we have a training2.jar. Okay, this is what we created just now. Right, right, right. 2146. And now what we do is scp training2.jar, and I'm saying root. I think it was root. All right. Right now I'm using Hadoop 3 dot no bigdata.com. I'm using specifically for MapReduce. I'm using a third server, Hadoop 3, and let me copy it to a folder called Sandeep. In case you guys don't know, in when you SCP, you can SCP to the server. Okay, and the format of SCP is that first command SCP, the source file, and then you give the login ID at the rate, then this, and then after colon you have to place a colon here. After colon you put the folder name. Okay, Now I'm opening another terminal and SSH Hadoop 3 nobigdata.com. And in case you guys are surprised, how come it did not ask me for the password? I have copied my, I have made my SSH password less. You too can do that. Okay. So here, this is my shell here. And if you go into Sandeep folder, you'll see this jar, training jar. I'm deleting the older one. Okay. Now you have this. I'm just checking the dates. Yeah, this is good enough to go. Next step is to execute it. Okay. If you just say Hadoop and say jar and then say training 2, it says give me the class name also. If you remember, we created a function called created a class called stub driver, which is the guy responsible for stitching our main code. Now it has executed our file. Our logic is it has executed, and our logic is saying that give me input directory and output directory. Now let me just give it my input directory and output directory. Let me just check. So Hadoop file system minus ls, and I say user dot root. It has got my folder there, word count. Okay. Now word count. It has got so many folders, output folders. I'll just delete output. Okay. And I'll just do RMR. So here there is a command called RMR. It deletes all the folders. Great. Now I'm left with only input directory in this folder. Let me see what is there in the input directory. Right. So there is a file called big text. Never worry. We can pass Hadoop FS. Okay. Now here we go. So this guy is telling us, asking us for our, okay. So we found out by using Hadoop FS that there is a, this is the folder where we are interested in. There is an input folder in it. We just say input. Similarly, we say output. Okay. Now this is going to take a bit of time. So if you see, map and reduce has started 0% and 0%, and it will be saving our output data to the right location. Okay. Now map reduce finished. It gave me complete statistics and also told me where is my output. Where is my output? Did it give any errors? No. It successfully ran. Good, good. It generally tells me output folder. Okay. Anyway, I would not mind it. So this is where we were saving. Let's do Hadoop fs minus ls. There are two folders. One is success, this signal, and this is part. So under the output folder, all these things you see part R001. Okay. If there are multiple parts here in your output, that means there were multiple reducers. Okay. Right now there is single part, that means there was single reducer. Okay. Now let's see this. let's say we want to do cat, and then we want to say part, part, and then say star. So everything which is there in the part will get printed. So Hadoop HDFS has a command called cat, okay, and there you can do all of this together, okay. Users, root, word count, output, part, star, and then you start doing all of. So it will start printing all the files in the output folder, starting with the name called part. So hope this was clear, or did I skip a lot of things? So all we did is first we created a mapper, we created a reducer, we stitched together using stub driver, then we exported the file a jar, okay. After we exported the jar, then we transferred the jar using SCP to the server. Then we executed our executed our job by specifying first Hadoop jar, then our jar file name, and then the name of our entry point, and after our entry point, whatever arguments are passed, they are handled by our code. You see this, these args, it's an array of strings, okay. Step drivers main args are basically the arguments you will pass here, okay. It will be up to our code how to handle the arguments. And how are we handling arguments? We are adding the first argument as the directory to our code, to our map reduce input, and this as the output, okay. Hope that was clear to you guys. Yes. Is it did I lose you guys? I mean, was I clear when I was describing it? Is there any part which I need to repeat just now? Yeah, the code is little too much. I mean, our map reduce was very simple when we were talking in terms of streaming job. And personally, I prefer streaming jobs more than Java way, because Java way requires too much of code, too much of ID, and but I mean, when you have to customize things, then you have to go this route. Okay, it is there is not much to do with the efficiency per se. Okay, there is not. Right. So yes, so rest of the things I will also discuss about, without, say you are writing a big logic. Now for everything, you can't really, keep on running it on Hadoop. The basic test cases you should be running on your local machine, right? Right. Anyway, we can run directly from Hadoop like Java since we are using Hadoop. Not really. I mean, it gives you a mock of Hadoop. There is something called Tool Runner, which tries to mock what Hadoop does to you. But there is a library called Tool Runner. You can give it your driver, and it will run in the in the Eclipse itself. You can run it there, then and there for the smaller inputs just to test it. Yeah. So similar to what happens in case the normal way of doing it. So you create another class called tester, in which in the main function of that tester you write to tool runner dot run Then you give the stub driver's name and it runs that. And whatever arguments you want to pass to stub driver, you can pass it there. Okay. Does it make sense to you guys? Or was it very irritating? Also, one more thing I would like to bring to your notice is that you remember our discussion earlier. Earlier, we had a discussion where we were talking about, I mean, what will happen in case we are using our jar, external files, external libraries, and all that, right? So Hadoop has come up with a variable called a command line argument. The way we were doing a Hadoop jar, my jar, then my entry point name, there is all the options you can pass here. Okay, so there is an option called libjars. Okay, so this libjar is the all the jars you want those to be uploaded. You want to be uploaded onto the uploaded and distributed all to all data nodes. Okay, so in case you have a local jar file on which your code depends, and you say you are sending emails to people, let's say your Hadoop job, what it does is it takes all the key value pairs and starts sending emails to all the people in the world. There are billion jobs. Okay, now let's just imagine that you for mass mailing you are using Hadoop. Okay, and in the mapper what you do is the key is email ID. Right, right. I will also take another few minutes of your time to describe you how to test in the Eclipse itself. So no worries, okay? No worries at all. Now let me describe you something here. So whatever jars, say SMTP jar you are using, or say you are using some other Facebook.jar, or whatever library is provided to you, and you are using that logic inside your map and reduce, you can take those jars and put it in basically here. Okay, you can say slash or tilde my jar dot jar. Okay, my dot jar, or say Facebook dot jar, whatever you want to do. So this is the some other somebody else's code which provides you various kinds of libraries. And when you do this, Hadoop takes a copy of it and hands it over a copy of it to each data nodes or task executors, which will do the job based on it. Okay, so this is the important part. Earlier there were various kinds of ways, but now thankfully in a newer version of Hadoop, I mean a long back, although 2.3 probably, they started provide supporting this libjars perfectly. Earlier what you had to do is you had to do SCP to all the data nodes available in the network and copy this your jar into exact same location where you are using, and then you can use that in your include that in your command line. But now that is no longer required. Or there were all sorts of headaches you had to do. You had to merge all the jars together. And jar I mean, I forgot to mention that a jar is basically nothing more than a collection of classes, a compiled code of Java provided by somebody else to you as a package. Okay, great. So the if I know this is too heavy for this, but remember that when you I mean just keep this presentation ready with you when you are trying with Eclipse. It won't be that difficult after a couple of tries. Okay, go through these steps from 1 to 13, and then you will be able to understand it quickly. Okay, and also remember that this libjar is one thing which is quite useful to people. in the sense that say you are using some other, you want to write the data to MySQL, you want to do all sorts of magic. In that case, you want to use external libraries. For that, you can use those libraries in your code, and then no, if you include that in your code, it will become a very, very big pain. It has to merge all the classes name together. Okay. Yeah. So if we basically fb.jar in our jar is a very difficult thing to do. Ideally, you just refer another jar, the classes in a jar. Okay. In Eclipse, we added hadoop.jar. Perfect question. So it does not actually bundle those jars into your output. Your output class, this you my example.jar, will only have those 4 files. And in case those jars are not found in the production, it will start giving you an error. Okay. It's a reference only. Yes. We added those jars, but those were just reference only. Okay. Now, in case you are using, since we were not using any other jars, then what is there in the Hadoop installation itself? So all of the jars are anyway with the Hadoop core library. Right? In case you are using third-party libraries, so you can bundle those together. Uh, Earlier, what we used to do is flatten all these files together, create a single jar, and then give it to Hadoop. Okay, meaning explode all the jars, put it in a single folder, zip them together, and then give it to Hadoop. That had a lot of headache. Okay, so this is how you can do it. So remember that part. Anyway, so who wants to take a break now? Because it's 10:07. So it says break. Okay, great, great. Okay, we'll meet after 10 minutes, which means 10:18 for me. Hi, I'm back. Hi, Shashank. I'm not sure if people will like to share their email ID or contact number. Let's have the discussion in that Google Plus community. Shared the link with you. Okay. It'll be better that if if you are discussing something, it, other people can also be benefited from that, and we can have the discussion in the community. Okay. So if you are not able to log into that community, let me know. So this is the community. Okay. Hi guys, I'm back. Are you guys back? So I'm not sure if people will like to share their email ID or phone number, but anything you want to discuss, let's have those discussions on the community. Okay. Yeah. Okay. Okay. Now, so the thing which we were discussing, great, great. So I think everybody is back. It doesn't show me that who is. Yeah. Great. Great. So I think everybody is back. Now we were discussing about. uh, Okay. So this example which I have just given is also available in our KMS. Okay. So it is basically the sample project is there. You can click on that and download it. Okay. And that's where the you will find two folders. One is for jars and other is for actual project. That either you can import it, that project, into your workspace and then fix your library locations, or you can just do it from scratch. It's up to you. Okay. Now let's move ahead and look at the test case. How do you do the testing? That's a very important part. This testing not only assists in actually making your code robust, it also helps you writing code quickly. Okay. So unlike your traditional testing where somebody else is responsible for testing, here you will be doing it to run the code. In the traditional systems, what you do is you generally run the code from Eclipse and it gives the output then and there. But in case of Hadoop, since Hadoop will be installed somewhere on the cluster and you are developing on your machine, local machine, so it is difficult to I mean, it is the whole cycle of uploading your file there and running it on cluster and then testing the output is a painful thing. Okay. Even for a single iteration, it'll take 5 minutes of your time and a lot of inertia. So it's better to build a testing way on the local machine itself. So here is the example. If you see, so first of all, we create a class called generally as a habit, as a convention, we keep the name of class suffixed with test. Okay. And then I'll show you the actual code. That will be easier to show. This is the one. Okay. No, it is little too bloated. Okay. Now let's just start from the top. The So here are all imports. Do not worry about the imports as you write the code. Eclipse will help you importing the classes which you're going to use. So first of all, in this is just comment. These are few global variables which we have defined here. These are just global variables which we have defined, you see. And important thing is setup. So in case of so here this is basically JUnit kind of testing. We call it MR unit. Okay, MR unit in which there are mapper reducer libraries together. So they are unit testing, as in each functionality you can test individually as well as together. Okay. So here, what are we going to do is first of all create a mapper instance of the mapper which we have defined. Then we create something called map driver, as in the guy who is going to run mapper separately, and then reducer, the guy who is then we create a driver for reduce driver which is going to run your reducer separately, and then we have a combined map reduce driver which is going to run your mapper reducer. We told map driver that this is my mapper. We told reduce driver that this is my reducer. We told map reduce driver as mapper and reducer. So now we have created three drivers. One is map driver, other is reduce driver, and third one is map reduce driver. Okay. Right, right. This is sort of a bottom up approach where we try to independently test mapper, independently test reducer, and then combine them together. This helps us say while you are writing your mapper itself, you should be able to test it. Okay. In the sense that am I getting the desired output or not? Is my code giving the right key value pairs or not? Okay. Now let's have a look at it. Now we have a function called test here. If you see, this is my function. Here, this is just a, a stub. So it says fail, means this will always fail right now. And this will always, these are skeleton actually. The one which I have coded is this portion. Test map reduce together. So I'm calling map reduce driver with input file input, and I have just defined a input in terms of pairs where I've given a value 1 as the key. This is my key, and this is my value. This is my another key. This is my another value. This is the input I have just prepared for my mapper to be given. Now I'm saying map reduce driver add input new pair 1, and the string is this, Sandeep Giri is here, and again MapReduce driver dot add input, then giving it a pair of values 2 and this. So this value, these two rows, basically these two rows or two inputs will go to your MapReduce. Okay, instead of reading from the file system or HDFS or anywhere. Right. So here, basically, you can test your MapReduce in the same manner, mapper and reducer in the same manner here. Instead of instead of using MapReduce driver, what you do is say here we call reduce driver. Okay, reduce driver, and say add input value, and we keep on adding input values. Okay, or you can say reduce driver and add input key. Add. Okay, like this set input key. We can set an input key basically for a reduce driver, it will be always a single key and multiple values. Okay, and then you say reduce driver dot dot run. That's it. Okay, this will give you a certain kind of local value. Okay, so this is how you test. So I just on prompt to give you an example of how do you test reducer by creating input values, okay, and then calling it and checking the results. And then after the result has come, you say result dot get result dot generally you saying result dot get, okay, get first you say, okay, you say get 0, this is your text value, and then under that you say get first, yeah, get first and guess second. Okay, this is how you call it. Okay, so second will be your second value and first will be your first value. This will quickly help you test whether your thing, here you can put assert, assert equals, and this is your key, and you can compare it to something. Okay, so basically this is a quick and dirty way I could show you how to test a reducer independently, but this one is important. So similarly, we have created these two rows, two lines. Yeah, so basically if you are writing your Java code, then you will have to go through all this pain. Okay, in case you are writing a streaming job, all could you do is cat your file and pipe it to your mapper. Okay, cat file, pipe, and put your mapper there. Okay, that's how without Hadoop you can test all your mappers. Okay, and after you sort this value, you can put your reducer there, and that's it. So you don't need extra tool. But in case of Java, since it has got types and all of this, you have to use maybe MR unit, or this is the best way to test your Java code or run your Java code. You define your test cases upfront first, and then you start writing your Java code. Let your test cases fail for the first time, and later on, I mean, you just write a skeleton of your map reduce code and let your test cases fail, and then you code against your test cases so that all of your test cases pass eventually. Okay, so you define an input, then you said map reduce driver run. It ran your mapper and reducer locally and gave your output in this format. Okay, it's a list of pairs of value. Okay, a pair contains two things, a, a key and a value, and then you can iterate over that. For pair P in output, print these values. So this is how you generally print it. So this, I mean, this is the way you test it. The important aspect in this is setup. In this, first you set up a driver for map, then you set up a driver for reduce. Both these places you define, you give out your stub mapper. Here you have given out your uh, reducer, and that's it. Okay, make sense to you? So this shows that same code again. So is this clear? Can I move on now? So basically what we did was instead of having that loop, right. Yes, Anto, I have not done that. I have not done any assertions here. Okay. You can do all of your assertions like assert here. You can do something like assert equals, just a second. Okay, okay. You can basically do all of this. Okay. Generally, these things are available if you extend a test case. Here, if you extend a test case, then basically your asset will be available here. Okay. Here, if you say p.get first, and then you say some value, okay, I say Sandeep. So in case this value is not matching, it gives error. Okay, and you can say asset true and whatnot. You can keep on doing this. This is pretty very useful library to us. Hello. Hmm. It suddenly started showing me some hardware error. Okay, okay, and yeah. So this is pretty much with respect to the Java thing. So everybody is sort of okay, although most of you are not. So in case you did not get this in first shot, look at this code once. Try to import the given project into your Eclipse. Download Eclipse, run Eclipse, and then download all these jars which are provided to you, and try to execute it as is, and then see if you are able to do it. Also, I will, in case you get any error while running it, let me know. I'll try to fix those problems. Okay. Right, I think what you call a test ng is basically, test ng is for the .NET kind of thing. Okay. Right. Basically it's the same thing what we do it in JUnit. Okay. So yeah, I mean these are standard ones. I mean these is basically JUnit and Mockito combined. And what test cases we have written in JUnit. So everything possible for JUnit should work on all your test cases. Okay, now let's move on. So till now we talked about how to basically write your mappers and reducers in Java. Okay. Okay, let me just take one more minute. So is anybody having a problem with this? Should I move on with the other concepts, or do you have any questions right now? Yeah, you all need to try it out. The project which I have uploaded onto the LMS, please use that one, import that into your Eclipse and try to run it. In case you run into problems, drop me an email. I will try to rectify it, or drop a message on the community, and then we will discuss it there. Okay. And come back with the questions next in the next session, which is tomorrow, or maybe after tomorrow. I forgot to answer Shashank's question. Shashank was asking if we are going to install Eclipse or Cloudera right now. No, I'm not going to install any of those things. And I have planned not to give the demo of installing Eclipse, sorry, installing Hadoop. Okay. The way which we are working out here is the way we are working out here is that we will be using the either either the I mean the ISO provided Cloudera ISO, Cloudera virtual machine through VirtualBox that will be your local, or you will be using the servers Hadoop 1, Hadoop 2, and Hadoop 3. Hadoop 3 is used for MapReduce specifically from the command line, while Hadoop 1 and Hadoop 2, the two machines, are being used for the graphical interface. Okay, I plan to merge them together very quickly. Okay, maybe this week, next week, so that you get a bigger space, more number of machines to experiment with. And probably name node we need to increase memory because it is shutting down again and again. Although it's 4 GB, but it seems that it is too less memory for Cloudera. Okay, so we have to increase that one. So for time being you keep on using Hadoop 3 for MapReduce related jobs, while Hadoop 1 and Hadoop 2 you can really Hadoop 1 basically Hadoop 1 uses a name node as Hadoop 1 and data node is Hadoop 2. Okay, so Hadoop 2 somehow the Hadoop 1 has started showing me that if you see those errors and you can try to figure out what is going on, it will be a good exercise for Hadoop administration. Okay. So Shashank, I will ask you to actually go through our Hadoop server, hadoop1.nobigdata.com, to understand it. Okay, it's actually installing to that point is easy, but administering Hadoop requires a bit of fiddling with the tools. Okay, so have a look at Hadoop 1.nobigdata.com and also come up with the suggest me what are the things that could be done in order to make that server better. Okay, and feel free to engage in conversation over community so that because right now we are completely disconnected from each other. Okay, now let's talk about something which is important here. So we talked about something called the chunk problem, right? Now let me just go into details about it. Hadoop, be, before giving the input to maps, create something called input splits. Okay, a quick recap: when there is a big file, Hadoop splits it into smaller chunks of by default 64 MB, but can be increased to any value which you please. Bigger chunk size means less number of nodes, and a smaller chunk file means the data is going to be distributed across. Similarly, when you are dealing with maps and reduces, before feeding to mapper, out of the chunk size, out of the chunks, out of the HDFS or the data input provided, Hadoop forms input splits. These are fixed size pieces. Okay, and these input pieces are one per mapper. Okay, and a description of one, one per basically a input piece is further divided into records. Okay, a record is something on which your mapper runs. Each mapper is given a record, key and a value, and the mapper will run on that and give the result. And there will be multiple such records in an input split. So you can think of input split as a part of a table. There is a huge database table, and that database table, some part of it is on one node and some part of it is on another node. Okay. A- and mapper runs on a set of these rows. Okay, each row is say a record. So out of the chunk size which is available, and generally input input split is created out of a chunk. Okay, and out of a chunk, input split is created. It might be combination of more than one chunk, but generally input split is closely matching with a chunk size. Now if you create too many input splits, meaning there'll be too many jobs. Basically, if you create a smaller split, there'll be too many jobs and there'll be high overhead. Okay, so chunk, when we talk about chunk in terms of HDFS, it is basically a file sliced at a fixed bytes into various computers. When we talk about input split, it's a portion of a input which is basically parsed or prepared by your code, by Hadoop or by your input reader, so that it can be completely fed to a independent process without worrying, without worrying of half of the word is here or half of the word is there. Okay, so those kind of problems are handled by the input split. I'll get into details. A good input split size tends to be equal to HDFS block. If the input split is too big, then mapper will take too much of time and will kill a single node. Okay, and mapper tries to create, Hadoop tries to create a map or an input split close to where the data is located. Okay, and this is called a data locality optimization. And mostly Hadoop will be running your data in a localized manner. Hadoop will be running your map onto with a data locality optimization. In the worst case scenario where none of the nodes containing the data is available for you, then in those special cases it will move it to another node which does not have the data. But further, there also it will do this locality optimization such that your mapper goes to a node which is closer to the data, as in, is it in the same rack or is it in the same data center? I will talk about more in details further how the topology works. How does Hadoop know that it is in the same rack or is it in a different rack? Okay, and in terms of Java, this is what a input split looks like. It has two methods. First, it has got a length, and second, it has got locations. Locations are nothing but uh, the locations within a file name and the number. Okay, or you can think of get locations as yeah, it's a basically file name and a byte number, an array of those. Okay. So this is what input split stand by default is. Now who creates these input splits? An input split is fed to a single machine mapper. On a machine, a data node will be executing your job. A job consists of say mapper. So a mapper will be applied on all records of a input split. Okay, of a input split, record by record. Okay. So a map will be applied on an input split record by record, and that is how we define input split. So your name node or your job tracker created input split. Okay, and after input split is created, Hadoop decides that who is going where. I mean, the same task tracker or job tracker decides where is your mapper going to go based on these locations. Okay. Is it designed to get data into complete object? Yes. Basically, that is the one objective of having input split, such that each each split makes some sense. It should not be that half of the word is this side, half of the word is that side. Now let's go back to our problem where we were talking in terms of sentences instead of lines. Okay. When we talk about creating the words, right? The problem which we started today with, we needed input in terms of sentences. If we could get the input in terms of sentences, then our job is finished. If our input is split is done in such a manner that each record is a sentence and it's an array of sentences, then we don't have to worry about anything. Okay. And that is why you generally create, sometimes you end up creating your custom input split. Yeah, example is coming on the way. Yeah, don't worry. Now you look at this is data locality optimizations visualization, where where this blue colored one is HDFS block while a green colored one is map task. Okay, in case these colors are wrong, then excuse me, pardon me, because I'm a bit of colorblind. So, so the green colored one, which is map task, okay, sometimes these are on the same machine. In the case where not on the same machine, map task and the HDFS block, they will be on the same rack at least. These are racks basically. There are three racks and each white colored one is a node. Then in the worst case possible scenario where the second one is not, B is not possible, then it tends to have on a different uh, rack but in the same data center. Okay, so this is called data locality optimization. Now let's take a case here. Now who creates these input splits? There is something called input format. Okay, this input format class is something which creates the splits for you. It has two methods: get splits and create record reader. uh, Shashank, which one do you want me to explain? The data locality optimization? Okay, let me just try this. So what we are trying to say is, say you based on input splits, Hadoop decided that your code needs to be executed at multiple places. The mappers need to be executed at multiple racks or multiple machines. But the places where your chunk is lying for each mapper, all of them are busy. All the replicas of that chunk are busy. In that case, it first it will try to execute your mapper on the same machine which contains the data for that mapper. Okay, same machine. In case that machine is not available, and or any of the replicas are not available, then in that particular case it will try to execute your mapper on same rack. You understand the meaning of a rack? Okay. Rack generally has a local uh, hub on which all the cables are connected there, then and there. So the data transfer happens amongst then and there instead of coming to the server, coming to a central place and back. right? And then we have if it's not possible to execute your code on that particular rack on which data is lying, then in that case it moves it to the different rack but keeps into the same data center. And if that is also not possible, then in the worst case scenario it will have to move to the different data center. I'll talk about this again in a minute. So this is called data locality optimization. And how does it decide which one is near and which one is far? Okay, I'll come back to that one. So there is a class which of type input format. In all the classes extending input format, there are multiple classes. There are binary input format, there are text input format, and there are all sorts of input formats. There are zip input formats. So they all extend input format, and what they do is they provide the functionality to functionality. They give a list of input splits locations, and each input split is nothing but a length and file locations where all it's existing, each input split. So in case you want to build your own, say, sentence input formatter in which each record is going to be a sentence, in that case you will have to extend have to extend input format and then implement the two methods get splits and create record reader. Oh, Chintamani, you lost a lot of things today, but never mind. Just go through the video once and we will discuss. In case you have a doubt, ping me. I will try to. Okay, okay. So I'll just go back to the first one where we started the whole discussion from, right here. So let's have a look at this. Mapper is being executed on each line, right? Each line. And that's where the problem was. We talked about two problems, right? Where, so that problem could be solved if the mapper is given the input in the form of sentences instead of lines. Okay? In form of sentences. Each record on which the mapper is going to get applied should be in the form of sentence. Okay, now how do we do that? How do we do that? And remember that the input you are getting right now is in the form of lines, right? So somebody is breaking the content of the files such that they each record becomes based on each record is based on new line rather than a dot. Okay, so you, which means that I mean you could basically change that behavior to, instead of break the whole text on new line, to instead of breaking it on new line you can break it on a period. Okay, so that is how, and how do you do that? So that's where the role of an input splitter comes into play here. So if you yes, yes, go ahead. Yeah, please go ahead. Bhagavad Shashank, please. Okay, so to prepare input split, or you want to customize input split, in those cases either you can extend input format or other classes which are deriving from input format, and there you can create record reader. Record reader's role is give you a list of records one by one, one by one. which you can feed to your mappers. Okay. So this is all you need to understand about input split and input format. In case you plan to extend input format, you can do that, and you can actually study a bit further to before doing that and go through a sample one. Okay, okay. So Bhagavat is okay. Bhagavat is not okay. He has a question related to HDFS splits. So to avoid the confusion between input split and the splits created by HDFS, I have used a word called chunk. So HDFS blindly took a file, cut it at exactly 64 mbth bit, and created these chunks and put it all across, right? But when you were given text input to your mapper, you were given full words. Okay. Now, if on a boundary where this 64th ambient bit is existing, if the boundary exists in the middle of a word, okay, what do you expect? You expect this to be sliced and put it across the two? No, you want it to be properly formatted. You want it to be in a format that makes sense, and that is why the input split comes into play. Input split is a logical way of looking at a data which can be fed to a single mapper. Okay, which can be fed to a single mapper, and each input split is basically a group of records, and each record uh, on each record we run our mapper code and gives the output, right? So no, it doesn't happen. Okay, so who will decide the input split, customize or default? So by default, the input split we are using here is called text input format. Okay, whose role is actually doing exactly this. The word should not the line, we should get line by line in each record. Okay, and similarly you can write your own. Okay, so how was this taken care? Good. Now let me a little bit explain. So we have got three lines: line 1, line 2, line 3. Okay, now let's just imagine here line 1, line 2, line 3. Okay, say line 1 is of size 30 MB. Second line is say line 1 is of I'll just say 25 MB, 25 MB, and 25 MB. Okay, there is a file of 75 MB which has got three lines. Okay, line 1, line 2, line 3. Line 1 is little too big, is 25 MB, right? Now the moment the chunks are created in a very awkward manner. So there'll be two chunks. Okay, this is chunk 1. Okay, this is chunk 1, and this is chunk 2. And chunk 2, what does it have? It will have basically out of line 3 it will be having portion of the line from the beginning till 14. Okay, and it will only have portion of line 3 remaining bytes. Okay, which is how much? How much is it? 11 MB. Okay, so So 14 MB of first line, okay, from the beginning of the line till that point is there and till here. Okay. So basically 64 MB and remaining goes here, right? Now when you cannot feed this kind of data to mapper, specifically the mapper which needs to operate upon line by line. Okay. Therefore, you need to re-prepare this data. In that case, what will happen is that these 11 MB also will get transferred here. And this is completely up to your logic. This is completely up to your logic. This is completely up to your logic which lies in here, in the input format. Okay. Whether to send this here or this here. Whether to send this 11 MB chunk from chunk 2 to chunk 1 or chunk 1 to chunk 2. It's completely up to your logic which you're going to write in the input format, right? So that is why this MapReduce Hadoop gave you a decent amount of framework to handle such kind of scenario. And similar scenario we were getting stuck where we want to process sentence by sentence instead of line by line. And therefore, to handle that kind of scenario, you might have to extend input format similar to the way text input format is implemented, where we split the lines by new line, we split the whole chunk by new line and then see if we have broken half of the line or is are we on the boundary or not. In case we are on the boundary, we request HDFS to get me the more data, and then also take a note that hey, this data is read, so that in the chunk mapper 2 it is not read. So I mean, all I'm saying is that you transfer this 11 MB to that side and tell that the another input is split, the data has been read. So this is the way we handle it, right? So similarly, the text input read similar to text input reader, the task was taken care by input this stream Hadoop streaming job. Okay, because Hadoop streaming job by default is basically a text input reader, whereby each each input value is a line, okay, to the mapper. And remember that we can operate upon binary files using MapReduce also. It is not only the plain text. Okay, okay. So streaming job, you remember I was showing you that there was there was a mapper file, there was a reducer file, all of that was happening. Okay, and the text was in the form of plain text, line by line. Okay, just go through that. So we were taking care of the line by line thing, and that's where it was being done by text input format. Okay, so hope this is clear to you guys. So this file got broken into two. Yeah, yeah. Okay, now let me move on. And this diagram further shows you the same thing what I was trying to show you. So by default, there is a text input format which does this job beautifully for you in case we have new line problems. I mean, if you just want to feed line by line to your mapper the way streaming job does or any Unix pipeline does, in case you want a custom one, okay, The way if you just needed say you are writing a natural language processing job, what you want to do is you want to handle one paragraph at a time in a map job. Okay, you want to handle one paragraph at a time in the map job. In those cases, you will have to use the your custom input format. Okay, so similarly this is the one. Okay, so this I tried to depict in the previous example. I can actually take this portion and keep it here. Okay, hope this is clear to you guys. Okay, now let me just, so this is these are chunks. If you see block boundary, block is equivalent to chunks what we talked about. I wanted to avoid using any other terminology. So HDFS blocks and HDFS chunks is the same thing which we talked about. These have nothing to do with sentence, word or anything. It'll just take a at the exact ith byte, it will cut it, the file, and keep it. Hey guys, give me some sign that you have understood, or if there is a question, just let me know. I'm afraid that I might have put you guys to sleep. Chunk size is always fixed, but you can configure it to on your Hadoop installation or HDFS installation. Basically, you'll have to configure your name node for chunk size. Great, great. Thank you. So at least Shashank is awake. Okay, okay, great, great. So Gaurav is trying to thinking it, right? So you can actually take a look at text input reader, text input class, text input format class. There is a class called text input format which extend input format. So once you have a look at it in Hadoop source, you will have the most clarity about how to write your uh, own handler. Okay. Now this question, let me see if you guys can answer this. Can reducer take a benefit of data locality optimization? The way data locality optimization was helping mapper by bringing the mapper closer to the data as much as possible, can can that happen with reducer also? Anybody? But remember that the what is the input? Interesting. Gaurav says not sure, but we can create reducer when the most of the data lies. Okay, 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 okay. So basically, input to the reducer is from all maps generally. Okay. So first of all, mostly the reducers are singular, as in generally reducer are either one, but by default are one. But you should always create multiple reducers. Also, the input to reducer is anyway going to shuffle it. Okay, so instead of worrying about sending reducers to the data, what people try to do is they execute reducer irrespective of the data. And this whole data locality optimization is improving day by day. Okay, it's improving day by day. So I mean, every now and then in every release of Hadoop there is a new optimization. Okay, and it's emerging. So maybe in future what Gaurav has suggested, they might include that kind of optimization. Now again, I'll go again with the same concept. Each input split is further divided into record. A map function is applied on each record one by one, and record is a logical entity. Analogy is your RDBMS row of an RDBMS table. Okay, or you can think of a record as in line of, or you can think of record as in key value pair of a hash table. So these are logical formats. Okay. Now there are actually some more things left. So see, Bhagavad, the problem is that your point is that the results of Mapper are being stored on a local drive, right? Now this whole data which is lying at 10 100 places at your local drive, at somebody's local drive and elsewhere, has to be reshuffled anyway. Okay, has to be reshuffled anyway, whether we do it on the local machine or elsewhere. Okay, so generally the way it would happen is, I mean, somebody has to merge all of this data together, right, after sorting it, and then redistribute it. Right, right. So see, so Gaurav's question is that we are trying to reduce, yes, we are trying to reduce a lot of data transfer, and there is a always, the Hadoop guys are always working on bringing more optimizations into place, such as such as that after the Hadoop, after Mapper have run, we have created these data files locally all across the nodes. Now we will first sort these all the files locally, and then see the data is where is it going to go. Okay, and after reshuffling, then we call the reducers. Though there is always a tendency to optimize the data transfer, but we don't call it data locality optimization. Okay. Okay, so while in the shuffling which is happening, there is a lot to be done out there. There are a lot of strategies, there are a lot of kind of algorithms which keep on improving day by day. Okay, so there are all tendencies is to have the data transfer centrally, sorry, data transfer minimized by having all sorts of things like pick two rows from one file, then pick, then compare which file was last one, or take 100 records from all the systems and then compare. All sorts of optimization keep on going all the time. Okay, but this sort of optimizations is generally not counted when it comes to the sorry, comes to the data locality optimizations. Right now it's not. Oh, sorry. Sorry. Okay. Is it audible now? Okay. Now let's talk about. Let me ask you another question. If you have to store a file with a replication factor of 3, how will HDFS store it? Where all it is. Right, right, right. So where all, what will be the tendency? So let's talk about the reducer's output. What is reducer going to do? Reducer is going to save its output in HDFS file. Now, when it saves this output in the HDFS file, which all nodes will be considered in saving this file? If you have a replication factor of 3, which all nodes, how will, on which all nodes will Hadoop store this file? Anybody? It has to store it on 3 files at least, right? 3 locations. What are those 3 locations going to be? I just described a sort of optimization. A task, right, right. Data node basically, which near the job tracker. Yes, yes. So near the task tracker basically, right? Data nodes, the data nodes which are near the task tracker. Okay. So the optimization goes like this. When you are storing a file onto HDFS, you first try to store it near to the you first try to store it near to the output node. Whatever data node you are running it, first copy goes to the data node. Now the second copy goes to off the rack. Not in this rack, some other rack. All the 2 copies will go in that rack. Okay. So Anto's question is how it will know which one is near. Just give me 2 minutes. I'm going to go there. Okay. So this diagram, I'm actually going back and forth. Basically the idea is to go a little deeper into the concepts. Okay. So this is how a single reducer works. Okay. So this is the one you want again, Shashank. So if you are going to store a file onto HDFS, so first thing it will do is store that file on that particular node where you're trying to store it, and on the nearest there. Say a data node is a job job tracker is a task tracker is trying to save a data somewhere. Okay, so first copy will be on the same node. Name node will tell him to store the file then and there itself. Once that is done, name node will tell him to store it off the rack on a different rack, the 2 copies of it. No, no, it's not on the same rack. That's a sort of optimization they did it. So basically, I mean, the idea is to first objective is to keep it fast so that the output of reducer is immediately available. Second objective is to have it reliable. Okay, and basically, uh, if you keep it on the same node or same rack, the reliability goes down because the chances of the same rack failure are higher than different rack failures. Now let's talk about this. This is the map reduce data flow with a single reducer, which we have already discussed. We have got split 0, split 1, split 2. We feed it to map. Map gives the output that gets sorted in the local copy itself. And once that is done, it gets copied at the central place where merge is happening, and then it is fed to the reducer. This is the case of a single reducer. Okay. This is the case of a single reducer job. The typical case of Hadoop streaming, where each job is a singular, each reducer is run only single times. And the part 0 I showed you in the output folder, there was only one file, part 0, part dash 0 dash 000. Okay, so right now there is only one file created in case of a reducer job. If you want to okay, we'll talk about that again. And here the thickness of the line shows that it's a network transfer, this one, and this one is your local transfer. Okay, and the tendency is to keep the local transfer as much as possible as opposed to the network transfer. Second, so this is how a single reducer generally works. So if there are too many reducers, the effort of shuffling is high. Too few reducers mean computation will take time because only one machine is doing the job. Okay, tune it to have total number of slots further. Okay, now the way you tune a number of reducer is number of slots available for execution, and the number of slots are basically decided upon total number of task nodes available in the task trackers available in your cluster. Okay, now and this number of reducers you can increase. Okay, after you increase number of reducers to more than one, this is how it is going to look like. Okay, can you see this? So here split 0, split 1, split 2 was fed to the mapper 1, mapper 2, mapper 3, basically same map together. Then the output was generated locally, data was sorted. Now, after the data gets sorted, it gets copied and merged onto two different machines on which the merge is happening, and it will generate basically part 0, part 1, two separate files if you have two reducers. Okay. Okay. Now there is another concept called combiner functions. Okay. Guys, just give me a second. I just get some water bottle for me and then come back in a minute. Yes, I'm back. Okay, so all right. S- So in terms of reducer, what does it mean? Okay. In terms of reducer, it means that basically there were two different machines on which the data was sent. But remember that all the keys, all the same key, basically there will be No such case that same key went to two different reducers. A particular key always goes to the same reducer rather than a different reducer. Okay, right. So here there is a division happening. Okay. Now there are cases where help, you want to help Hadoop to decide on which keys go to reducer 1, which all keys will go to reducer 2. Okay. And in the for that purpose, you can write other kinds of jobs. Okay. Now I will talk about it very quickly. There is something called combiners also. Okay. Combiners. What is the role of a combiner? Combiner are run locally just after the map is finished. Here, after the sorting has finished here, okay. So after the split was fed to the map gave some output went to somewhere. Okay, okay, this diagram is wrong actually. So there are some combine. Okay, let me take a good example. Okay, I got the example now. Okay, let me explain combiner and I'll answer everybody's question. So, do you remember the frequency of characters question? We were talking about frequency of characters, all right? Where what we were doing is we were counting the number of characters in each file, right? Now, it would have been great if just after your mapper code has run or mapper code has finished generating the frequency of each line. Okay, so your mapper code will generate the frequency of characters of each line, and then all of these outputs are combined together, become the output of the map. So for each line, map is going to generate the consolidated frequency of each one, right? And there are going to be so many such things because mapper is going to get executed on each line, right? So it would have been great if all of the output of mapper gets combined together before it gets transferred to another machine, right? So uh, I mean, I think I should just type somewhere. So you have got let's say A B C D, and then you have got again A B C D. Right now when this goes to your mapper, what are you going to do here? You are going to say A3, and then you say going B1, C1, and D1, right? Similarly here when it goes to your mapper is going to convert it into A2 and B1 and C1, D1. Remember that this is happening on a single node. This is a record 1 and this is a record 2. This is a record 2. These are all part of the same input split. Okay. These are all part of same input split. So it has got two records, this and this. When your mapper ran, it gave this output, and in case of second record, this it gave this output. So the consolidated output you get is this one. Okay, you got this as your consolidated output of map on that machine. Now in and similarly There'll be another machine, another data node which has generated the same thing, this, somewhere else also. Now they have to be combined together. Okay, it would have been great if we could just consolidate it here itself before before the merging happens, because that will tremendously improve the merging. Here there might be a a thousand rows, right? There could be a million rows here, but if you could merge it, it will become 26 rows, right? It will become 26 rows before getting transferred to another place and getting sorted with the other guys. If we could just merge these things, merge the output of the mapper together to generate a smaller output, then it will be just wonderful. And that is exactly the role of a combiner. After the after the maps output has been sorted, okay, so basically this is going to get sorted like this, and then you can run a combiner on top of it. It'll make your life very simple. Okay, the code of a combiner is very very similar to, or I mean you can say it's identical to your reducer. You again extend reducer and then write your combiner. Okay, this is what it does. So your combiner, what it will do is start from the top and keep reading a and say a is 5, and then this is 2, and this is 2, this is 2. Now your data has just shrunk tremendously. Now input shuffling amongst multiple task nodes for the preparation of the input to the reducer has gone tremendously optimized, right? And this is exactly the role of a combiner function. Okay, so combiner's role is exactly that. It it runs on the same node after map has finished, processes the output of the map, okay, helps in minimizing the data transfer, does not replace the reducer. Okay, also there are few more properties of a combiner function. First, it is defined using the same logic as reducer because its behavior is exactly same. It's a reducer running on the same node. It's a reducer running on the same node. Okay, the other property of a combiner function is that it should be idempotent. I don't like this idea of keeping it idempotent. What is idempotent? Idempotent is a function no matter in what way, or you can just remove this output, no matter in what way it is applied. You can, okay, let me just say this way. No matter how, no matter in what way it is applied, output should be same. For example, let's take a case of maximum, right? If you take a case of maximum, whether you do maximum of these four values together or you split maximum such that maximum of these two things, and whatever comes out to this, then compute the max of those things, output is going to be the same. Okay, this is not really idempotent, but it has got a property that on howsoever we are going to apply it, we used to call it some other method. Okay, so it is going to be same. Max is one such function, sum is another function, and all that. Okay, so this is a property it is supposed to have. Average is not, mean is not. Right, right. You're right, Gaurav. Okay, and in the job as we defined in our Java code here, you see our driver, the way we have here set mapper class, similarly we have set combiner class. Okay, we can say again the same stub reducer you can write here. Okay, it accepts that one. Okay, so it is not giving any error. So this is what a combiner means. So it combiner basically combines the output on the same machine. It is as if there was a single mapper in the whole job, and reducer is being run on top of it. The only thing is, a, a combiner might be run in parts or in the whole, howsoever. So it is similar to how should I explain? So this is a good example. Max function is a good is a candidate for combiner, because if you do max of all, it is going to be same. Or if you do max of this part and then max of this part, and then you compare the output of the two, again the output is going to be same. Similarly, sum is one such function. First you sum these two parts, so, and then sum these two parts, and the sum all, it is going to be same. Whether you sum this or sum this, then it is going to be same. Okay, but average is not. So if you say average and I say 1 2 3, okay, is how much? 2, right? In case we say average of 1 and 2, it is 1.5. And then we have average of 2 and 3. Sorry, average of 3 is basically 3. And then if okay, how this is one average. It is not equal to, it is not equal to average of, average of 1 2 and average of 3 4, let's say. I'm not sure, but generally it would not be. If you do the computation, it would not be. So not all aggregate functions can be combiners, because average or mean are also aggregate functions. Okay, so that's the role of a combiner. Because when I don't like this idea actually. Okay, I personally don't like it. uh, I have given it a thought. It should not be this way, because it limits us a lot. It limits us a lot. But Hadoop does it this way. It will keep on applying the your combiner function on each piece of the same file, say in locally, while sorting the data or giving the output of the multiple rows. Okay, okay, right, right. So let me just move on. Although combiner is a good idea, it is just this small piece where it says that I will apply uh, your functions on portions of the records, and then it will apply it in whatever way I want, which I don't like. Okay, now once we are through with combiner function, so should I complete it or should I leave it in between for tomorrow? I wish to complete it today. It'll take 10 more minutes. Is that all right? Okay, great. Great. Okay. Now, another part is partitioner. Partitioner helps in dividing the keys to various reducers. Which keys will go to which reducers, such that it becomes easier to divide the data amongst the reducers. Okay, so basically say we want to divide, we have a good number which says that males and females are equal in number. Okay, so in our record, if we find male, we say that send this to the first reducer. If we find female, send it to second reducer. This way, we can mark the we can mark the distribution of keys amongst the multiple reducers. And this is a good example. So if you are trying to divide the data, basically if we have three reducers, for first one we want to basically first one is for dedicated for people of less than 20 age, second one between 20 to 50, and third one is above that. Then we go for this kind of logic. We return ith number of the job. Okay, that's how it is done. So this is a code which return the partition integer. Basically it returns an integer based on the input value. Okay. Okay, this is specifically for deciding which keys go to which reducer. Great. Now network topology. Great. Now we are almost through. 5 more minutes and we'll be through. We've already talked about most of it. So in a network, there is a switch. To a switch, multiple racks are connected. Rack 1 and rack 2. And on each rack, there is node 1, node 2, node 3. On each rack there is a hub, or there is a hub which connects all these nodes and makes the data transfer amongst node 1 to node 2 faster than from node 1 to node 4. Okay, because node 4 is on another rack altogether. Okay, and when we count the distance between two nodes like node 1 to node 4, what we do is we find the common ancestor of node 1 and node 4, which is the switch, and count the length 1 2 1 2. So total distance between node 1 and node 4 is 4. Okay, while the distance between node 1 and node 2 is how much? Only 1, only 2. Node 1, node 2. Okay, distance is the common ancestor is this guy, this router, and 1 plus 1. Okay, so sum of the distances from the common ancestor of the two nodes is the distance between the two. Okay, so can somebody tell me what is the distance between say node 2 and node 5? What is the distance between node 2 and node 5? Okay, okay, so it's 4. Perfect. Right. And similarly, the way where we represent the network topology to Hadoop is in terms of similar to file system, a/a/b/a/b/c, like this. So we give names to all these things in that fashion. We'll call this guy, this person, as switch 1 slash rack 1 slash node 1, switch 1 slash rack 1 slash node 2, switch 1 rack 1 slash uh, node 3, and so on. Switch 1 slash rack 2 slash node 4. This is how the tree is represented in the file system as well. So this is how we tell to Hadoop that this machine's name is this, and hence you take care of and you can further put your mathematics in place. Okay, now how does Hadoop know how to tell Hadoop that which machine belongs to which switch, or what is the path of that machine? So there is something called DNS to switch uh, mapping. There is also a class, I mean there is also an interface which we can implement in Java and tell this tell name node that this is what is our switching mapping. And whenever there is an IP address Hadoop encounters, it converts it into slash a slash b slash c. Okay, kind of format. And similarly, there is also a way to give over your script file. I mean Unix script, if you are great at Unix script. And what you have done is whatever IP is given to this guy, you just convert that into slashes. Okay. Okay. So let's say a simple, a very, very, very rudimentary mapper would be say 10.5192.168.1.1. Your mapper is, all it is doing is it's converting it into slash 192 slash 168.1.1. Now, I I mean, this is just a very simple example. Okay. And you have written a script file which does this. So Hadoop will ask your script file, ki what will be the path for this IP address, and your script file will return this. Okay. And that is how, and on this basis, it will analyze which nodes are closer. Okay. Also, you could keep whatever way you want to keep. Okay, that will be up to you. Basically, Hadoop will give you the host name and the IP address. Basically, it will give you the IP address of all the nodes. It will call your script. It will call your script with the array, with the argument as an array of IP addresses, and your script has to respond with the path path name, and based on this path it will compute which ones are look nearer to it. Okay, so I will again try to put it here. Now it is called switch 1 slash rack 1 slash node 1. Okay, while this one is node 2. Okay, this is how the representation will happen. And node 3. Okay, and node 4 and the rack 2. Okay, right. So this is one example of converting your path. You could also maintain a big hash or a file containing all these mappings. If your network is not that uniform, you can keep a big file containing these mappings, and whenever Hadoop is asking your script, so you tell Hadoop by the way of specifying an option or parameter key to topology.scriptfile.name equals your script, and this script does all sorts of magic of translating an IP address into path. Okay. And I mean, you could do any kind of thing which you like to do in that script. Read from a database, read from somewhere in the file system, read from anywhere. Okay. Or does a magic juggling like replace dot with a slash, as simple as that. Okay. But all you need to convert it into a path format, a slash b slash d. Basically, this is the way a tree is represented. Right. So yeah, but most of the, actually any tool you see, they do a lot of their job by taking a very very default safe defaults, but they also give you an option to configure everything. Right. Just like database or just like any other operating system, most of it is a combination of development plus administration and a lot of other kind of skills. Okay, now looking at these two nodes, right, it's a suite of product, and that is why there are a lot of components to it. Okay, now let's have a look at the distance. So if you see the bandwidth If the bandwidth, if the nodes are closer, the bandwidth is highest. If the I mean nodes are very different on the different data center, the it is going to be very different. So the distance between this and this is 3 plus 3, which is 6. Okay, you would, look at these numbers. Okay, and then you will understand. So how many slashes difference are there? 1 2 3 plus 1 2 3. Okay, 6. Here the difference is R1 R2, 2 plus 2 4, and so on. Okay, now you can visualize it. There are two data centers, D1 and D2, and there are under the data center D1 there is R1 rack 1 and rack 2, under another data center rack 3 and rack 4, and there are on rack 1 there are so many nodes, rack 2 there are so many nodes, and these are the distances. Okay, and this is how you compute the distances. The mapping from an IP address to distances is done by your script. Okay, so this is pretty much for today. We are running quite late. I mean, we are 20 minutes above the total time. Okay, any other questions, or should we wind up now, or let's take up the questions tomorrow? So tomorrow we are going to discuss what is pig and related things. Okay, so we are going to cover pig most likely. Okay, and we will be covering questions today, and we don't think we'll be covering any more of Java, so do not worry. And okay, so feel free to drop me a message. And right, we'll have mostly practicals. First I'll cover theory part, and then we'll show you hands-on a bit of examples, and then see. Okay, great, great, cool. Then good night guys. Feel free to drop me a message in case you are stuck somewhere, but try that Java project at least once on your local machine. It will give you a good control of the whole thing. Good night Shashank. Good night Chintamani. Good night Andrew. Good night Arun. Bye bye Gaurav. Bye Bhagwat. Bye Hari. Are you there? Bye Suksavat. Okay, good night. Bye bye. I have to log off quickly, and bye bye.